Okay, protocol prop comedy. Yeah, yeah. I've been kind of distracted AFK with a few things. Summer's weather's been nice and all that, but also I've been kind of hitting a roadblock here with the rendezvous layer. I was writing code based off what I wrote in the spec, and it just wasn't coming together. And eventually backed up and had to work on this state, sort of a state machine diagram. But yeah, I'm kind of using analogies. So I remember, yeah, at least there was at least one discussion with Super Testnet about, cables plugging into other cables and kind of figuring out the analogies. And they're not perfect analogies, but I kind of have those analogies here, and I have a few props and stuff I'm just going to go through here. I won't go through the details of these state machines because, yeah, they look pretty ugly. I'm just going to kind of go in the high level of kind of what these three different things mean. And then, yeah, if this means something to you, or if you have any thoughts. But yeah, it's mainly useful for me to just be able to explain it once and see if it makes sense to me before I get too invested in tests and code and all that. So this is the rendezvous layer. So this is one layer above the basic, either TCP or WebSocket transport. And the goal of this protocol is to make it, for lack of a better word, plug and play. Is like simple little applications like Moneysocket chat and all that. Whoever's developing these applications, they don't want to get overwhelmed with complexity, because they want to make like a little app, and they want to just use the basic part of Moneysocket. They want to fit into the ecosystem. So we want to support lots and lots of little apps like this and make it easy to write. But at the same time, we're also imagining more complex things like financial dashboards and message relay networks that are paid and stuff like that. But at the very basic level, so the design has to cover, essentially what I'm saying is the design has to cover the whole spectrum. But it's very important to get the simple part working. So kind of the prop is, kind of the analogy is a USB mouse, in that the context of what this is very clear from just how it is. This is a very simple device. You're plugging it into a more complex device, and the more complex device does kind of the heavy lifting. But there's a whole ecosystem of vendors selling simple little USB devices that do one thing, and that's kind of what I want to enable. But then also figuring out, okay, well, what's the other end of the equation for that, of all the complexity. So in the rendezvous layer, to support that, kind of like when we have these simple devices, it's sort of deferring the complexity to the higher devices, and then sort of the state machine here is very straightforward for how it works. And yeah, I just kind of, in this diagram here, like this is again like if you're doing like a hardware device, you just want to do the basic implementation of Moneysocket to be able to fit into an ecosystem. So the back end of a device can be the complexity, and then the user's wallet that walks around that's doing all these fancy user interface things. That can become more complex. So that's kind of that. But there's also then the idea of having two simple devices. Like, it doesn't make sense to plug a mouse into a mouse. There's sort of like these peripherals, kind of, you don't even think about, it doesn't make sense to plug these into each other on the simple side. And in the same way with this chat, if you have a chat window and then like a different chat Twitch app, you're not going to try to connect these two. That kind of doesn't make sense. Sort of what this is self-apparent from its presentation. So it's kind of the protocol needs to err out with that, if and I guess USB kind of made these connectors sort of only one way, like male and female. You can't actually plug them into each other. But yeah, like somebody's going to try, and at least the protocol should error out. So that's sort of an important thing. But I guess because this isn't quite the same as USB. The idea that we have these relays, which I guess the analogy I'm using there is like a switch, like an Ethernet switch is kind of the same thing as the relay.socket.money. It's like these are kind of like silent devices on the network that provide sort of a service to get devices connected to each other. It sort of hides all the complexity of matching peers to each other. So that's that's kind of the stand-in idea that I have for the relay, even though it's not quite, this might imply some other things that don't make sense in Moneysocket, but do for Ethernet. But yeah, kind of the idea is if you have two simple devices, they can talk to each other through, USB hub is not quite the right analogy here, so I'm not going there. This analogy kind of breaks down because they're both input devices, maybe an input and an output device like a monitor and a mouse, plugging in through a relay or something would make sense, in whatever the Moneysocket imagining of that scenario is. But the idea is like these guys are still allowed to be very simple, and then if you do need to plug them into something and it does make sense, at least this is supported, and you're not burdening these guys with implementing all the fancy networking logic. So yeah, that's this sort of simple path, and in the handshake, this is a role. So when a device connects, it announces itself as one of these three roles: a relay, a complex, or a simple, and then the state machines, based on how those things collide, it evaluates. So that's fairly straightforward. I think that's good and all. However, this does, when you unpack it for some of the more complex things. So the analogy of extending USB. So now in the modern era, we have these USB-C connectors that are the same on both ends. So that's not quite. And then Apple is very aggressively pushing these types of connectors for everything. And in fact, the other day, this is a couple of weeks back, my friend's MacBook Air, my phone's battery was dying, and his MacBook Air had battery. So I connected one end here and then one end into the MacBook Air, and it actually did it backwards. The laptop started charging off of the phone. So that's sort of an edge case where this kind of falls apart. There's no sort of big little implication when you plug a mouse into a computer. There's sort of, this is the little device and the computer is the big device. When you start getting into these bidirectional things and you're plugging a phone into a phone or a phone into a laptop, what each of those roles on either end starts to be kind of crazy. It breaks apart, and then you're kind of relying on the fact that these devices have screens and user interfaces, and sort of once you connect it, the software is kind of then configuring how it's supposed to work in handshake. So kind of like a typical thing, if you have your mouse connecting into your laptop, this would be something like Moneysocket chat as the mouse, and then your laptop, something complex is like your wallet UI. That's fairly straightforward, simple, complex. It's sort of when you do that, then the complex thing takes over and starts telling it how to work, and then you proceed from there. But then, there's ambiguity once you start connecting a complex into a complex. That's a little bit nutty. So that's where we get into this. So the state machine has the notion of a tiebreaker. So when your phone and your laptop handshake, there's sort of a random number that says, all right, well, if we're at a stalemate, this tie-break number, whoever has the highest number, is then going to take the matchmaker role, or sort of is going to finish the rendezvous handshake, and the other one's going to be sort of the subservient. So there's kind of baked in that if there's ambiguity, it's at least a coin toss, and for most of the time, that's enough to then you're kind of deferring to the higher levels of the protocol to then go figure it out. And then you're kind of keeping this idea that's just plug and play, plug that into that. And then the devices will do what they can to disambiguate what you mean in the best way possible. So that's where, if it's simple, complex, it goes through sort of the basic, and then if not, it goes through the tiebreaker, and then we know which side is which role in the handshake. Based on, so these two requests get sent on the wire, and they cross, and then and they both identify themselves, so each side then knows how to proceed based on that when these two things have crossed on the wire. So then we're getting into the relay. So the relay is also a participant. So the way the rendezvous works. So like in this case down here with the the relay and two devices, they both connect in and they say, hey, I'm looking for my friend. Hey, I'm looking for my friend. And then the relay matches them up. And then once they're connected, they forward the messages, and there's end-to-end encryption, so the relay can't read what the messages are. So that's the service, and then that's useful for, as we've discussed previously, for defeating firewalls and other networking circumstances. Is that even relay.socket.money, it's insanely useful for being able to do this. To allow your wallet and the apps and all that connect seamlessly. So this is a pretty important thing, as our network switches. So that's kind of the analogy that I'm on there. So the problem is like when you have one of these complex devices and they're intersecting in this, what's actually being done. But at the very basic, if either a simple or complex, if they provide a rendezvous ID, the relay can then hook them up with whoever they're looking for. So that's the basic thing. But then where to go from there? The idea that, and this is where we get into the more complex things, the way you might want to chain relays. And then we've also talked about, and I'm putting this as a big TBD, the idea that we might want to have onion routing. So the way that Lightning Network is passing in-band messages, this is a way where we could do the same thing across relays, where we're not restricted by the onion packets of the in-band protocol. And then there's ideas of paid bandwidth. There's Impervious.ai had their announcements about paying for transfer bytes, and maybe that makes sense in some circumstances as a spam reduction thing. But kind of the idea is that you might want to chain. You might want to have relays talk to other relays in the same way that you have a switch, where you can just kind of daisy chain a bunch of switches and they figure out how to route from one end through the intermediaries to the other end. So I'm kind of thinking about that, and right now, because this is getting pretty complex, I kind of want to get everything else implemented before I worry too much about that. But yeah, so I'm kind of leaving that as a gap in the state machine. In the meantime, I'll just error out there, but I am thinking about that. And I think it is very important. It's too big of a problem to really worry about from the current vantage point anyway. This is different than what I wrote in the Moneysocket RFC, so I'm going to have to update that and probably get this implemented. And actually implementing it is then the test of whether this actually makes sense, to make sure that there's not actually holes, because in the handshake, there's messages crossing each other on the wire in flight. So making sure that they land in the right way at the receiving end. But yeah, so this is just a basic. This is a more clear imagination of what I wrote in the spec, and I'll have to formalize that. And then also providing the tests of this code actually executing through all these cases is then also pretty important. And then the next step on top of that is the actual encryption layer, which I've talked about noise protocol a bit. But anyway, we're coming up 14 minutes, so that's more than enough. So yeah, thanks for listening.